Cool.
I'm Amanda Skinner, and these are my high school physics students coming in to tour the circuits lab, hoping to get some interest in the programs here in town. Look like they're having a lot of fun. We're glad to be here today.
All right, thanks.
Here you go into 3 different classes, which is going to be controls, process. This is a multimeter, and what I did is basically just make sure that we don't burn. Because think about it, light. If you put too much power to a light, it doesn't have. After you do it, you have to have a vertical challenge. That's what basically we're trying to teach you guys. So that's more on the computer science part right there, or the networking part. That's more of that end right there. And we integrate everything. Here you can see the Ethernet cables. They're actually communicating already. And so everything. It's here at Williston State College. If I wanted to purchase one of these trainers, it will cost us 40 grand. It cost us, because the students made it, they made it all the way from design phase. They thought about it, okay, how are we going to do this? And they made it from scratch. And now here's the final product that's done, the working model. And we probably have spent probably a couple $100 because everything else was donated by industry. They liked the project, they thought the project was real cool, and they helped us out. Triangle donated this part right here, the wiring. Border States donated the viral frequency drive, and Whiting Petroleum donated the motor. So as you can see, we get a lot of donations, and we just put it together. And it's a real cool experiment that Steve's group, he was the one involved. He's a graduating senior here in May. And as you guys can see, this right here, this is what's called the variable frequency drive. I don't know how familiar you guys are with it, but basically what it does, it controls that motor. So what it will do, it will slow down the motor, it will make the motor go faster depending on the application that you're doing. So kind of a blender, think of a blender. If you're actually, doing ice, you want to put it real high. If you want to just do a little puree, you just want to put it slow. The same thing, but now you can do with a motor. And everything's controlled by this device. And this device, you program it. Just like you do the PLCs, you will program it in this device. And you get it to do whatever you want. And the good thing about this device, it also has an Ethernet port, so you can communicate and control it with your cell phone, wherever you want to. All this right here is created, is all 480 volts, because this motor needs 480 volts to work. So as you can see, what we've done is we've done a safety enclosure here. Look at the size of those fuses, because everything's 480. The motor works on 480, and what we do is the students design a movable trainer, because we don't have 480 in this room, we have 480 in the next room. So we have to transport over there whenever we need to. And, it's what you guys are going to see out there in industry. So basically, should we have a lock there? Once we energize it, and we're going to turn it on. See, it's disconnected right here. These are disconnect. Here are the fuses. You're able to power it. And the motor, you turn it on, slow it down, do whatever you want to that motor. Reverse it, which then, if you didn't have this device, it would be hard to do. And then, of course, it helps the grid, because it controls the amount of current that the motor will be drawing. Any questions on this project? Each one of these equipments, we have here $100,000 for both. They're brand new, they just came last semester. So all kinds of sensors, you got PID controllers, you got differential pressure sensors here, you got electromagnetic sensors, you have level sensors, you have more sensors here, so it's full of sensors that kind of mimic what a plant does.
I got it.